সো আজকে আমাদের যে টপিকটা আমরা পড়ব সেটা হলো অ্যাসিড বেসেস অ্যান্ড সল্ট। ফার্স্টে আমরা বুঝে নেব হোয়াট ইজ অ্যাসিড। সো দেখো, কোনটাকে অ্যাসিড বলা হবে কিংবা কোনটাকে বেস বলা হবে, হুইচ এভার সাবস্ট্যান্স উই আর গোয়িং টু কল অ্যাজ অ্যাসিড অর বেস ডিপেন্ডস আপন সার্টেন প্যারামিটার্স। ঠিক আছে, লাইক ইউ ক্যান সে কার্বন ডাইঅক্সাইড is acidic, but you need to support this by some logic. So primarily we are going to go for a single logic, that is acid in aqueous solution gives away H plus ions and base in aqueous solution gives away OH minus ions. This theory was given by Arrhenius. So by Arrhenius theory we are going to understand acids and bases. Okay, so Arrhenius theory, what did Arrhenius theory said? It says if there is a acid named Ha, so this is a general term, and if you put this Ha in water, then this is going to dissociate. Ha will give away H plus ion, which will combine with H2O to form H3O plus ion plus A minus. This ion is named as hydronium ion. So basically this acid gave away H plus ion, and this H plus ion combined with water, that is this one, and gave you this H3O plus. So whenever you put any acid in water, it is going to combine with H2O to give you H3O plus, that is hydronium ion, that is as per Arrhenius theory, and this kind of substances will be termed as acids. So we can write down acids in aqueous solution. Acids in aqueous solution gives H plus slash H3O plus ion. Okay. So this is acid. Now coming to what are bases. Bases on the other hand can be generally written as BOH, and when this combines with water, see this is B plus and OH minus, so it will give away OH minus ion, and this B plus is going to get hydrated. You can write B plus aqueous, that means B plus is surrounded with water, this water. So whenever any substance is giving OH minus in aqueous solution, it will be termed as base. So base gives OH minus in aqueous solution. Bases give OH minus in aqueous solution. This OH minus is named as hydroxyl ions. Hydroxyl ion. Okay, gone. This one is done. Now based on amount of dissociation, that is, suppose I have an acid which gives H plus plus A minus in aqueous solution. Another acid is also there, say I am naming it as HX. In aqueous solution it also gives you H plus plus X minus. However, in the first case, the amount of H plus produced in the first case is much more than in the second case. So if the amount of H plus produced is more, if H plus produced is more, then you can say HA is a strong acid. Okay, then you can say HA is a strong acid. So if acid dissociates highly, if acids dissociates highly in water, then it will be termed as strong acid, otherwise it will be termed as weak acid. If base dissociates highly in water, then it will be termed as strong base. Then it will be termed as strong base. Okay? If the acid dissociates highly, it will be strong acid. If the base dissociates strongly, it will be strong base. Now, what are normally strong acids? Example of strong acids are like HCl is a strong acid, HNO3 is a strong acid. So this kind of acids are also called mineral acids because they are derived from mineral. So this kind of acids are pretty strong because when you give these acids in water, then they are going to produce lot of hydrogen ions. Okay? Example of strong base: so NaOH is a strong base, KOH is a strong base, then barium hydroxide is a strong base, etc. Now coming to weak acid, all organic acids are weak acid. Like any organic acid, like formic acid is a weak acid, acetic acid is a weak acid, oxalic acid is a weak acid, then anything else like carbonic acid is a weak acid, H2CO3 is a weak acid. Weak base, classical example of weak base is NH4OH, ammonium hydroxide is a weak base. So any metal which is much metallic, its hydroxides will be a strong base. If it is not that much metallic, then its hydroxide will be a weak base. It is not going to give you much OH minus in water. So, this NH4OH is not going to dissociate highly in water, and that is why it will be termed as a weak base. So, this is the basic understanding of strong acids and weak acids, strong base, weak base. Next, metals plus acid. Metals plus acid. So, how do acid behave when it reacts with metal? So, before going into this, we need to know the metal activity series. So, metal activity series is K, Na, Ca, Mg, Al, Zn, Fe, H, Cu, Hg, Ag, Au, Pt. So, this is the total metal activity series. This is very important and we need to remember this. So, why this is important? Because any metal when reacts with dilute acids, any metal when reacts with dilute acids, this metal displaces hydrogen from acids, but there is a catch. What is the catch? Catch is this metal must be above hydrogen in metal activity series. Must be above hydrogen in metal activity series. Now, how does this reaction takes place? Suppose I take zinc, classical reaction, zinc, and the acid must be dilute, not concentrated. So, and I react it with HCl. So, here H acts as electropositive one, Cl acts as electronegative one, though it is not a ionic compound. So, writing this plus minus is not technically correct. However, for understanding purpose we are using it. So, this zinc is going to replace the place of H, because zinc is much more metallic than H, zinc is much more electropositive than this H. So, zinc combines with chlorine. Now, zinc has a valency of 2. So, zinc combines with chlorine to form ZnCl2. How will I find this? You have to write zinc like this, you have to write chlorine like this. Zinc has a valency of 2, chlorine has a valency of 1, cross multiply, find out the answer. Don't try to just replace it and write here ZnCl plus H2, 0 marks. So, to balance it, 2 HCl and H2 is going to get liberated. So, any metal above hydrogen, that is any metal above hydrogen, that is up to this, will be able to do this. Potassium 2 ion, every metal will be able to displace hydrogen from dilute acids. Okay. However, if the metal is below hydrogen in metal activity series like copper plus HCl, then there will be no reaction. Okay. Then there will be no reaction. Now, the next thing is, there is another acid, that is nitric acid. Nitric acid, even if it is very dilute, then also it is a very good oxidizing agent. It is a very good oxidizing agent. Even if it is very dilute, then also it is a very good oxidizing agent. So, As nitric acid, even if it is very dilute, it is a good oxidizing agent. What happens? Nitric acid reacts with zinc. Suppose nitric acid is reacting with zinc. First, zinc is displacing this hydrogen and hydrogen gets liberated. But nitric acid, on the other hand, it's a very good oxidizing agent. So, the nascent oxygen from nitric acid is going to oxidize hydrogen to water. So, what will happen? This hydrogen is not going to get produced. Whenever you talk about nitric acid, na, if suppose it is zinc plus nitric acid, so there are various critical reaction over here depending on the concentration and the temperature of nitric acid. So we are just going to understand the part which we require. The hydrogen liberated gets oxidized to water. Why? Because nitric acid is a very good oxidizing agent even if it is very dilute. But it has been possible for us to react magnesium and manganese with very cold and dilute less than 1% to liberate hydrogen from HNO3. So it has been possible, but only for these two metals. So we need to remember this, can come as a question. Only for these two metal this has happened. Okay. Next we go for reactions of acids with carbonates and bicarbonate. So basically we are not only doing acid, we are also revising chemical reaction and changes, the first chapter, chemical equations and all. So what happens if any carbonate reacts with an acid? So I am taking a very simple carbonate, calcium carbonate. When it reacts with dilute HCl, it gives salt plus water plus carbon dioxide. So this is how will you form the salt. This salt will be formed by the cation of the carbonate and the anion of the acid. So see, cation of the carbonate is calcium, anion is chloride. So here the valency is 2, here the valency is 1. Please cross multiply and find out the formula of salt, CaCl2 plus water plus CO2. So this is not balanced at this moment. So you need to balance this. Now this is balanced. Okay. So this is how any carbonate is going to react with dilute acids. Any carbonate. Okay. So this has nothing to do with metal activity series. Any carbonate will react in a similar fashion with dilute acids. And important thing about this reaction is carbon dioxide is going to get evolved, and so there will be a brisk effervescence. As an observation. This is one important thing, and also if some linked question is asked, then you need to remember carbon dioxide turns lime water milky. Lime water means calcium hydroxide. Lime water is calcium hydroxide, turns it milky. Okay. Now we will go for bicarbonates. So I will take calcium bicarbonate only. Bicarbonate has a valency of 1 and calcium has a valency of 2. So calcium bicarbonate is CaHCO3 whole twice plus HCl. So bicarbonates and carbonates have not much of a difference. The reaction is same, salt plus water plus carbon dioxide. The salt will be calcium chloride, same, carbon dioxide CO2 plus H2. This will be 2 HCl, and to balance it 2 CO2 I think, yeah, and to water. I think it's balanced. Yeah. So same to same, everything is same, observation is also same. So calcium bicarbonate and calcium carbonate doesn't give any different kind of reaction with dilute acids, it gives same kind of reaction. Okay. So now we will be going into the sulfites and bisulfites. So first of all, you guys will try sulfites and bisulfite plus HCl. So this is a reaction which we will try. So I will give you one sulfite Na2SO3 plus HCl, this reaction you will do, and next is KHSO3 plus HCl, this reaction you will do. Okay. So this will be NaCl salt plus, in place of carbon dioxide it will give you sulfur dioxide, simple, plus H2O to NaCl, everything is balanced. In this case same KCl, in place of carbon dioxide here will be sulfur dioxide plus H2O. I guess this is already balanced. Yeah. So this is balanced. Now here the observation will be, again, gas evolved has smell of burning sulfur. So this smell is like the matchstick burning smell, nothing else, burning sulfur. Okay. So this is how sulfite and bisulfite reacts with dilute acids. So any dilute acid is going to react with sulfite and bisulfite likewise. Next, H2S plus, sorry, sulfides, S2 minus plus acids. So we will take a sulfide Na2S plus acid, say HCl, dilute acid. So the reaction is very simple. Sodium will go with chlorine, so it will form NaCl plus H2S. So simple, 2 NaCl plus H2S. Here there is a characteristic smell, rotten egg smelling gas is formed. Okay. So this is how sulfide is, any sulfide is going to react with dilute acids. Okay. And the observation is very important. So that is almost all the reactions of acids except the basic reaction of acid, that is acid plus base gives salt plus water. So that is, we are going to do just one reaction for that, for the sake of acid plus base. So suppose there is a base NaOH plus HCl plus HCl gives NaCl plus water. Simple. Okay, this is a very normal reaction. Now in the first part, we knew that when a metal reacts with acid, it gives you hydrogen. But there are certain metal which gives hydrogen with base also. This kind of metals are called some people call them as amphoteric metals, because these metals react with acids to give you salt plus hydrogen, also reacts with base to give you salt plus hydrogen. So this is zinc, lead, aluminium. Reacts with both acids and base to form salt plus hydrogen. Reacts with both acids and base to form salt plus hydrogen. We are going to see an example. Zinc plus NaOH, an equation from NCERT. So it forms a salt. Sodium zincate, Na2 ZnO2 plus hydrogen. Okay, very important. Now in case of this base should be concentrated, this is not dilute. For this reaction to occur, this base should be concentrated. Okay. Now let us go for lead. Again concentrated. Na2PbO2 plus hydrogen. Okay. So this is called sodium zincate. You need to write the name, sodium zincate. This reaction is there in NCERT. This reaction, and this one is called sodium plumbite. Sodium plumbite, not plumbate, plumbite. Next, aluminium. This has two reactions. Aluminium, when reacts with fused NaOH, fused means molten, no water, fused NaOH, it gives you Na3AlO3 plus hydrogen. However, the same aluminium when reacts with concentrated NaOH, gives you NaAlO2 plus hydrogen. Now you will not be able to balance this reaction if you don't put one water over here. Now you will be able to balance this reaction. 2, I think this will also be 2. This is called sodium aluminate. This is called sodium meta aluminate. The names are important. All these reactions are important because one reaction is given in NCERT, that is for sodium zincate. Otherwise we should do all the reactions over here. These are very preliminary reactions which should be done. Next, as we have already discussed that NaOH plus HCl is going to give me NaCl plus water. This is discussed. Similarly, if it is a metal oxide and it reacts with HCl, metal oxide is also a base, so it will give you the same reaction, nothing different. It will also give you NaCl plus water, so it doesn't change anything. So metallic oxide is also going to react with your dilute acids to give you salt plus water. Metallic oxide reacts in the same way as does metallic hydroxide, because all these reactions are aqueous phase reaction. These reactions happen in water medium, that is aqueous medium. So in water, Na2O is going to dissolve in water to give you NaOH, so there is nothing difference. Na2O is going to dissolve in water to give you NaOH. So what is the difference? There is no difference between these two. So that is why the products are same, products are not different. Okay. What happens if I react some metallic oxide with base? Metallic oxide or rather hydroxide with base. So see, metallic oxide or rather hydroxide is base only. So what will happen if they react with base itself? So in natural thinking, there should be no reactions, right? So actually metallic oxide, if you react NaOH with KOH, there will be no reactions. There will be simple no reaction. That's it. You can just put NaOH and KOH in a bowl of water. Nothing is going to happen. However, if I put zinc oxide or zinc hydroxide in NaOH, there will be reaction. Because these metals, that is zinc, lead and aluminium, these three metals I have already discussed, these are amphoteric metals. So whether it is zinc oxide or zinc hydroxide, these are amphoteric compounds. Amphoteric means they can react with acid, they can also react with base. So we will take one. We will just take one example on this. Zinc oxide. Zinc oxide, if you react with HCl, it is going to give you ZnCl2 plus water. Okay? But this zinc oxide, if you react it with NaOH, it is going to give you again salt plus water. What salt? Na2ZnO2. Na2ZnO2 plus water. You can easily balance it now. It's balanced. Okay, Na2ZnO2 plus water. Done. So here also you can see that this metallic oxide is reacting with a base. Metallic oxide is reacting with a base to give you salt and water, and because here it is acting as an acid. It is normally a base, but when it reacts with strong base like NaOH, it will act as an acid. Okay, same will be the case with lead and aluminium also. So what I'll do is, what I'll ask you to do is, do this reaction with aluminium oxide and lead oxide at home. Do this reaction with aluminium oxide and lead oxide. Now the question is, what kind of salt will be getting produced? See, the type of salt that is going to get produced is already discussed over here. If you are using fused NaOH, then it will be sodium aluminate. Concentrated NaOH, you will get sodium meta-aluminate. And for lead, it is simple sodium plumbite, so there is no discrepancies there. So use this fundamental and find out the products when this lead oxide and aluminium oxide is Al2O3. Lead oxide you will take, basically PbO you can take. Okay, and find out when it reacts with NaOH, or rather you can take KOH also. These two reactions happen with strong concentrated base, KOH, NaOH. So do this, and if you can do this, then you will be able to find out confidence in doing chemical reactions. Okay. So next we are going to do, or we are going to study about strength of acids. So strength of acids basically depend on amount, or rather concentration of hydrogen ions, because when we studied this, the first one, let's go to the first one, this acid definition, strong acid and weak acid. Okay, here, if the acids dissociates highly in water, it is called a strong acid. So if the acids dissociate highly in water, then H plus produced will be more and it will be a strong acid. So this, how much amount of H plus is produced, will dictate the strength of the acid. So strength of the acid is dependent on concentration of H plus ion. Okay, based on concentration of H plus ion, strength of acid will be calculated or found out. So this is basically found out by a scale that is called pH, small p capital H, potential of hydrogen, potens hydrogen. So this is mathematically minus logarithm. Logarithm is a mathematical operator, base 10 H plus ion concentration. Okay, so this is what pH is. So suppose in an acid H plus ion increases. So if H plus ion increases, see there is a negative sign over here, then pH will decrease. Okay, if there is lots and lots of H plus ions, pH will be less and less. If there is lots and lots of H plus ion, pH will be less and less. So that is why, therefore I can say acids will have low pH. Acids, rather strong acids, the acids which are strong will have low pH. Okay. Now if there is less amount of H plus, there is no H plus, let us take no H plus, there is almost very negligible amount of H plus. So H plus, if H plus ion concentration decreases, then if this one decreases, there is negative sign. So that means pH will increase. pH will increase. So this shows that where the H plus ion will be less, in basic solution H plus ion will be less. So that is why strong base will have high value of pH. High pH. Strong base will have high pH. Weak base, or rather strong acids, will have low pH. Okay. So there, based on this, basically there is something called pH scale. So pH scale is from 0 to 14. There is a midpoint which is 7. Now this 7 indicates if the pH is 7, suppose if the pH is 7, this indicates the solution is neither acidic nor neutral, nor basic, sorry. The solution is neither acidic nor basic, the solution is neutral, neutral solution. pH is equal to 7 and it indicates neutral solution. This pH paper has different shades of color on it. So in this side this is red color, and this side, in 14 side, it is blue color. So it generally changes from red to orange to yellow to green, then to deep green, and suddenly it changes to blue. At this point, this 7 the color is green. So sometimes question may be asked, in neutral solution what will be the color of the pH paper? The answer will be green. If it is a strong acid, answer will be red. If it is strong base, deep blue. Okay. So this is how it is. This is what pH is at this moment. That is what we have to study. That is the amount of pH that we need to understand. Okay, but it is very important if you consider on chemistry point of view or various application point of view, because based on this pH we all should know something about the economy of our country, because see, whatever subject you are studying, at the end of the day it has to have a positive effect on the economy of the country or your surroundings. So our, at this moment also, if you see, our economy of the country is mostly dependent on agro based product. Okay, so directly or indirectly approximately 45 to 50% of our population is dependent on agro based job. They are related directly or indirectly with the agricultural economy. So in agriculture, pH is very important, because certain crops are there which are not going to grow in basic soil, they are going to grow on acidic soil. Certain crops are there, they are going to grow based on, say, basic soil. So this soil analysis by pH papers or pH measuring instruments is very important. So pH plays a very important role in this kind of testing of agricultural land. And many a times what happens, you have to choose various fertilizers or additives to be given on the land before sowing the seeds of excuse me, before sowing the seeds of certain crop, because that crop demands that pH, and suppose your soil doesn't have that pH, it is more or less near about that. So what you will do, you will find those chemicals which are going to increase or decrease pH in such a way so that you can grow that crop in your field, whatever field you have. So that time you need to buy that chemical and put it in the field before sowing the crops, right? So that is the kind of importance that pH has on our agricultural field, and it is very important. Please, nowadays what happens, we ignore agriculture. Okay, we can write on Facebook and everywhere that farmers are dying and everything, but practically speaking, we who are living in urban areas, we are least concerned about the exact economy which is happening in the rural based economy. We are least concerned. Okay, sometimes we are seeing that farmers are dying and we can write down something in internet, but normally we are not interested. But you should be interested actually, because at the end of the day, if that is a supply chain for you guys, if that stops now, everything will stop. Okay, this computer, this whatever we are talking about, headphone and everything will not work as long as it is working, because your stomach is full. If that doesn't work, nothing will work. So this kind of examples are very important. And not only agriculture, pH plays a very important role in our digestion system also. You must be studying biology and you know things about this. Like when acidity increases, we have medicine that has magnesium hydroxide. Magnesium hydroxide. The gelusil we have nothing but magnesia, that is MgOH whole twice. This helps to reduce acidity. This helps to reduce acidity. Magnesium hydroxide helps to reduce acidity and is used as an antacid. You can write down antacid, used as an antacid, important, can come in examination. pH of the soil, pH in our digestive system. Then our tooth may decay if certain if the pH falls below 5.5. That is also important. So pH should not fall below 5.5. Okay, so you cannot have acids to destroy your tooth. So this kind of applications are very important, and I think for Cbse examination point of view, what you should do is you should study. There are around 4 to 5 applications given in your textbook. You study them very carefully, and for examination point of view, I am saying but normally I think you should go deep dive into this small applications and understand the implications of that. Definitely will help you. Okay, so that's all about acids and bases. Now we'll be discussing a little about salt. So see, there are basically three kinds of salt. One salt I would name as normal salt, or rather neutral salt, and there are certain salts which we can call as acidic salt or basic salt. So there are many kinds of salt. However, I'll stick to the syllabus. I'll take three salts. One is NaCl, another is NH4Cl, another is CH3COONA. So if you talk about this NaCl comes from NaOH and HCl. So NaOH is a strong base and HCl is a strong acid. So whenever any salt is coming from strong acid and strong base, and if you put this salt in water, it will give you a neutral solution because it is coming from strong acid and strong base. So both are going to get neutralized basically. However, if you talk about this NH4Cl, it is coming from NH4OH, which is a weak base, and it is coming from HCl, which is a strong acid. So if you put this in aqueous solution, it is going to be acidic. On the other hand, if you take this one, this is coming from Na is coming from NaOH, and the CH3COO is coming from acetic acid. So we all know that NaOH is a strong base and acetic acid is a organic acid, so it will be weak acid. Acetic acid is a organic acid, so it will be weak acid. So ultimately this will be in aqueous solution, this will be basic, okay, because it is coming from a strong base. So this process of dissolution of salts to get either a acidic solution or a basic solution is basically called hydrolysis. So when you get an acidic solution or basic solution, it is called hydrolysis because there is some change, right? From salt you are getting some acid or base, so there is some change, it is called hydrolysis. It is a chemical change happening. But on the other hand, if you put NaCl into water, there is no change, it remains neutral. So hydrolysis never occurs in NaCl. So this is very important. NaCl, no hydrolysis. Salts from strong acid and strong base will not undergo hydrolysis. Salts from strong acid, weak base, hydrolysis. Salts from weak acid, strong base, hydrolysis. Weak acid, strong base, salts from weak acid and strong base will give you a basic solution. Salts from strong acid and weak base will give you an acidic solution. Okay. Okay. So that is the basic understanding of salt. In next class we are going to do the other salts that are there. Are certain salts in your syllabus like bleaching powder, NaCl and all. So that those preparation we will do in detail, ठीक है ना, in next class. Okay.